let's get started. So for the string manipulation, okay, so remember with the move instructions, say for example, I have here move num and variable. This is what? This is not valid instruction because you're moving data from memory to memory. Okay, so uh, so since we're dealing with the string, so what do we mean by string? String is a collection of data, which are, since it's a collection of data, we cannot use register for that because what's the maximum size that your register can have? So if you have 2 bytes, you have 4 bytes, and you have 8 bytes. But if you have more collection of data, so that means you have an array of data, you need a memory location for that. So for you to be able to process the string, you need to make use of the memory location. And for you to be able to access or to address memory, we will be needing addressing mode for that. So basically, the operation for the string manipulation is whether that is a move or the load or the stores or the compare or the scass, we will be dealing with memory addressing mode. Okay, so in that case, for these are the pre-processing or the 5 things that you have to consider when doing the string manipulation. So the first one is the address. So since we are dealing with memory to memory movement or memory to memory evaluation or byte by byte data in a collection of bytes, we will be using the different segment. Okay, so the first thing that you have to consider or to do in string manipulation is to initialize your data segment, the segment registers and the offset register. So this is the segment registers and this will be the offset register. So how do we do that? So basically we have the data segment. Okay, so we declare all the variables, source, db, that's rows, say for example, and then you have the destination db. So you have here 10 dupe with initial content of $sign. So under the code segment, so we have here the main procedure. Okay, so we will do initialization of your segment. Okay, so since luckily the the source and the destination belongs to the same segment. Okay, so which means, what does it mean? It means that we will be initializing the segment registers for that. So to do that, we have move ax at data and initialize your data segment, so ds ax, and of course your extra segment, so move es ax. Okay, so, however, say for example in a given you have data for the source, so db, you have rows, and for the destination, so you have your data 1, so that's another segment, so so we have here db and do $sign. So for that, in the code segment, so you have here the main function, we have here move ax at data, so we have move ds ax, and we need to initialize that with another segment. So with that, we will be using again move ax, this time at data 1, and move es ax. So that's the first thing we have to consider. We have the data segment, so this is checked, and the extra segment, this is also checked. Okay, so next. So let me just make it a little small. Okay, so moving on. So the second thing that you have to consider is the offset address. So once we've already initialized the segment register, so we will be initializing also the offset address. So we've already done this before. Now you just have to take note that as the DI is the destination index and the SI is the source index. So with that, so load effective address SI, what is the string or the memory location that refers to our source? We have here src. Load effective address DI, so that will be your DES. Ganyan lang. So we're done with the DSSI. Okay, so the second thing that you have to consider with the string manipulation is the direction flag. So what do you mean by direction flag? So direction flag sets, so since, say for example, I have ROSE, I want to move or copy the content from a source to the destination. So this is a different memory location, assuming that this is 100 and this is 150, correct? So once I've already manipulated, say I've already copied this to 100, from 100 to 150, how do I proceed to the next memory location? What do? I need to increment the source index and also increment the destination index. So this process of increment is done by the direction flag. Okay, so direction flag automatically increments the offset address. So now you have to consider, so we have two types of two settings for the direction flag. We have the clear direction flag, we have the CLD. So we have the CLD. So this is CLD, and we have the STD. So CLD and the STD. So when we said CLD, that means you increment. Okay, and if you say STD, that means you do the decrement. So as you can see here, so you have to consider that if you start from the first element, okay, from the first element, that means you have to increment your way to the last element, correct? Okay, so in that case, so how do we do that? How do we declare? So we will be using CLD or STD. What are we going to do? So we will be using the CLD. So in CLD, okay, so that means, what does it mean to have, so what does it mean to use CLD? Okay, so it means that you have to start from the first element. Okay, so your source index offset and destination index offset should start from the first element. Okay, so moving on. Okay, so what if, say for example, so what if you have that is STD? So if you will be using STD, that means you will start from the last element. So in that case, so load effective address SI, what is our last element here? E. What is the address of E? So 100, 101, 102, 103. Okay? So that means, what does it mean? It means that we will be getting the address SRC plus 3, which is the address of the last element. So as the destination. So load effective address destination index. So we have destination plus 3. And then, that's the time we can use the STD. Okay? Okay. So we're done with the direction flag, with the address. So this time, the next thing that you have to consider is the count register. So you have to initialize the count register. So to initialize the count register, you just have to know the size of you have to consider the size of your strings. In this case, what will be so move cx is equal to 4. Okay, so move cx is equal to 4. That's the number of characters in the string. Okay, so done with this. Now we proceed with the prefix. So repeat not equal, and repeat equal. So we will be discussing this in the next slide. So first, now I have a question. Okay. Can we interchange the step? Can we interchange the step? Okay. If yes, what will be the arrangement? Okay, so you can interchange this one. Okay, so you can have this interchanged or this. How about the source index and the destination index? Can you have this interchange? No. So you really have to start from the segment register. But these three, so this, and this can be interchanged. Okay, so provided it will occur prior the string instruction. Okay, so the three of this can be interchanged. So step 2, step 3, and the source of the offset registers, initialization of the offset registers can be interchanged. Okay, so let's proceed. So here are the different prefix. So prefix for the different string instructions. So these are the different string manipulation instructions. So we have the move. So when we do the move, the direction will be, what will be the direction? From memory to memory. So we have here memory to memory. Memory to memory. So this is the source, this is the destination. How about, so it can come into variation with byte and words. Okay, so next one is the STOS with also byte and word. So what will be the movement of your data here? So the movement will be from CPU to memory. Okay, so CPU to memory. So store. So whatever the content of the accumulator, you will be storing in the memory. Load, on the other hand, the movement is vice versa, which means from memory to the CPU. So depending on the size, so if that is byte, it goes to the lower accumulator. If that is word, it will go to the whole accumulator. Compare string is the same as the move. So there is a memory to memory comparison, both on byte and words. And lastly, we have the SCAS. So the SCAS compares the content of the CPU against the content of memory. So what I remember here is S. So S sounds like CPU. So STOS and SCAS starts from CPU. Anyways, so now I've introduced the different instruction or string manipulation instructions. So let's proceed with the prefix. So for the prefix, what do you mean by prefix? So what's the idea behind the string manipulation? It can perform loop. So why do we need loop? Because you have collection of data. So to be able to perform loop, so in the previous examples that we're doing, so loop you use for loop. But in string manipulation, you can use equivalent that is in repeat. Okay, repeat equal or repeat not equal. Okay, so repeat can be used to can be used if you are not getting any comparison. So, for example, you don't have to test a flag for that. Okay, you just, regardless whether that is the same or not, whether that is same or not the same, you will just proceed on doing that. So that means it is used for the movement and storing the content from the processor to the CPU. From the processor to the memory rather. So load, on the other hand, does not use a repetition. Why? Why do you think we cannot repetition is not used in the load? Okay, so say for example, um, you will be loading the data rows, okay, to the accumulator. Okay, so if I will use repeat here, okay, so that means it will stop until the whole characters in the string is loaded to the or yeah loaded to the to the accumulator. So meaning it will just overwrite. So if I will do repeat, it will just overwrite whatever the content of your accumulator. Okay, so say for example R. So repeat load S. So that means R will go to R will go to AL. So repeat, so that means it will make loop. So what will happen? O again goes to the R, but it will be the first content will be replaced by O. Okay, and so on and so forth. Okay. The one that makes use of the repeat equal or the repeat not equal are the compare string and discuss string, because primarily because you're comparing the content of the memory. So from the discuss, you're comparing the content of memory to memory, and for discuss, you're comparing the content of the CPU in AL against the content of the uh, mem- uh, memory. Yeah. Okay.